The future of electric vehicles in 2025. The electric vehicle, EV revolution, is no longer a concept of the distant future. It's happening now. In 2025, we find ourselves at a crucial tipping point where consumer demand, technological advancements, policy incentives, and sustainability goals are converging to shape the future of mobility. From automakers doubling down on EV production to governments enforcing stricter emissions regulations, the world is transitioning toward an electrified transportation ecosystem. This comprehensive guide dives into the current state of EVs in 2025, explores the breakthroughs pushing the industry forward, and highlights the challenges that remain. Whether you're an EV enthusiast, a potential buyer, an industry professional, or just curious about what's next, this pillar page has everything you need to know about the future of electric vehicles. The EV landscape in 2025 marks a pivotal moment in the global shift toward electric mobility. EVs now account for more than 25% of new car sales in some regions, with countries like Norway, China, and the Netherlands leading the way. The push for electrification is no longer driven solely by environmental concerns. It's fueled by economics, consumer preferences, and policy mandates. Major automakers have committed billions to phase out internal combustion engines ICEs in favor of EVs. Tesla, Rivian, BYD, Ford, and GM are racing to capture market share, while startups like Lucid, Fisker, and NIO continue to innovate. The rise in EV adoption market trends. In 2025, the global EV market is projected to surpass 20 million annual unit sales, a dramatic rise from just a few years ago. Several key trends are driving this adoption. Falling battery costs. The price of lithium-ion batteries has decreased by more than 80% over the past decade. Expanded model availability. From luxury sedans to budget hatchbacks and rugged trucks, there's an EV for everyone. Incentives and tax credits. Many governments offer tax breaks, rebates, and perks like free tolls or access to carpool lanes. Total cost of ownership, TCO. EVs are cheaper to maintain and fuel over their lifetime compared to ICE vehicles. Consumer attitudes are also shifting. Surveys in 2025 reveal that more than 60% of new car buyers are considering an EV, and nearly half of Gen Z drivers say they only want electric cars in the future. Third game-changing EV models released in 2025. 2025 has seen an influx of new electric vehicles across all price ranges and vehicle classes. Some of the most anticipated releases include Tesla Model 2, a compact, affordable EV starting under $25,000. Ford F-150 Lightning. Gen 2, improved range, faster charging, and more towing capacity. Volkswagen ID.7. Tourer, a sleek electric station wagon built for families. Hyundai Ioniq 7, a full-sized electric SUV with Level 3 autonomy. Chevrolet Equinox EV, a budget-friendly crossover with a 300-plus mile range. Rivian R2S, a smaller, more affordable version of the R1S SUV. These models reflect broader design trends: longer ranges, faster charging times, and increasingly autonomous capabilities. 4. Battery technology. The heart of the revolution. The key to EV performance is the battery, and 2025 has brought major advancements in battery tech. Solid-state batteries. Companies like Toyota and QuantumScape are rolling out early versions of solid-state batteries that offer higher energy density, faster charging, and longer lifespans. Silicon anode batteries. Improving charging speed and range by increasing battery capacity. Cobalt-free chemistries. Addressing ethical concerns around cobalt mining by switching to lithium iron phosphate, LFP, or nickel manganese chemistries. Battery as a service, BAS. Some automakers now offer battery subscriptions, allowing users to upgrade or swap batteries over time. Breakthroughs in battery recycling are also making EVs more sustainable by recovering up to 95% of materials like lithium and nickel. 5. Charging infrastructure. Faster, smarter, ubiquitous. Charging is no longer a bottleneck. In 2025, ultra-fast DC chargers, 350 kilowatts plus, are becoming standard, delivering 80% charge in under 10 minutes. Wireless charging is emerging, especially in urban environments and taxi fleets. Bidirectional charging, V2G and V2H, allows EVs to power homes or sell energy back to the grid. AI-powered route planning ensures drivers always find available chargers on long trips. Countries are investing billions to expand charging networks, and private companies like Tesla, Supercharger, Electrify America, Ionity, and ChargePoint are leading the charge. 6. Software and connectivity in EVs. EVs in 2025 are smart, connected machines. Key software trends include over-the-air OTA updates that continuously improve performance and add features, personalized AI assistants integrated with voice control and predictive driving tools. 7. Autonomous driving and EV synergy. Autonomous tech and EVs are developing hand in hand. In 2025, Level 3 autonomous driving is legal in many places under specific conditions. Robo-taxis and autonomous delivery vans are operational in urban centers. Companies like Waymo, Tesla, Mobileye, and Cruise are deploying fleets of self-driving EVs. Electric drivetrains are ideal for autonomy. Fewer moving parts, lower noise, and better integration with advanced driver assistance systems, ADAS. 9. Sustainability and environmental impact. Beyond tailpipe emissions, the environmental impact of EVs is improving. Renewable energy integration. Many EVs are now charged using solar, wind, or hydropower. Sustainable manufacturing. Automakers are cutting emissions at factories and using recycled materials in interiors. Battery recycling and reuse. Programs are emerging to repurpose EV batteries for stationary storage after vehicle retirement. Life cycle emissions of EVs are now significantly lower than ICE vehicles, even accounting for battery production. 10. The role of legacy automakers versus startups. The battle between old and new is heating up. Legacy OEMs like Ford, GM, Toyota, and BMW are investing heavily to electrify their lineups. Startups like Lucid, NIO, Fisker, and Rivian are innovating faster and experimenting with new business models. Partnerships, mergers, and acquisitions are rampant as the industry reshapes itself. 11. The supply chain challenge, chips, lithium, and beyond. EV production faces key supply chain issues. Semiconductor shortages continue to delay vehicle deliveries. Lithium demand is skyrocketing, prompting new mining operations and recycling efforts. Geopolitical risks in regions that produce rare earth minerals, e.g. China, Congo, threaten stability. Shipping and logistics are being reimagined to meet just-in-time EV manufacturing. Supply chain resilience is now a major focus for every automaker. 12th. Second life batteries and recycling innovations. What happens to EV batteries after the car dies? Second life applications. Used EV batteries are being repurposed for home energy storage and grid stabilization. Recycling startups like Redwood Materials are creating closed-loop systems to recover valuable minerals. Legislation in places like the EU requires automakers to recycle or repurpose batteries. This circular economy model reduces environmental harm and ensures long-term resource sustainability. 13. Commercial EVs, trucks, vans, and public transit. 2025 isn't just about passenger cars. The commercial sector is electrifying fast. Electric delivery vans from Rivian, Ford, and Mercedes-Benz are common in urban areas. Electric buses are replacing diesel fleets in cities worldwide. Heavy-duty trucks from Tesla Semi, Nikola, and Volvo are hauling freight on electric power. Fleet management platforms optimize routes and charging for efficiency and cost savings. Commercial EVs offer major emissions reductions and fuel savings for businesses. 15. Challenges holding EVs. Back in 2025. Despite massive progress, challenges remain. High upfront cost. EVs are still more expensive than ICE vehicles without incentives. Charging deserts in rural or underserved areas. Battery raw material scarcity, especially lithium, nickel, and cobalt. Public skepticism around range anxiety, safety, and long-term reliability. Grid strain, increased EV adoption, places stress on power infrastructure. Solving these issues is essential for mass market adoption. 16. What the future holds. 2030 and beyond. Looking ahead, more than 50% of new car sales could be electric by 2030. Full level 4 or 5 autonomy may be commercially viable. Green hydrogen and solid-state batteries could redefine EV capabilities. Vehicle-to-grid, V2G technologies could turn EVs into power plants on wheels. Hyper-local manufacturing might reduce shipping emissions and costs. The decade ahead promises even more disruption. 17. Conclusion. Why 2025 is a defining year for EVs. 2025 stands as a landmark year for electric vehicles. It marks the end of the early adopter phase and the beginning of true mainstream acceptance. With better range, smarter features, broader model selection, and stronger infrastructure, EVs are no longer an experiment. They're the future of transportation. Whether you're considering buying an EV, investing in the industry, or just curious about where the road leads, 2025 is a turning point you can't afford to ignore.